So we have enough people. I think we can start on time, finally. So, yeah, thank you for coming. My name is Viresh. I work in the PMWG work group in Linaro, and I have been using Git for maybe like 7, 8 years now. And there have been a lot of chances where I have found that some of the commands, when they are tweaked, or some of the practices, when you can do it certain way, they really help. Most of this presentation is going to be about or around rebase, because that's where actually people can save time, a lot of time. There have been cases where I have like 50 patches in my branch, and I have to play with them all day long. I have to like start rebasing in the morning, and till evening I'm just rebasing, just to fix minor things in the patches. And with these tweaks, I have experienced that it can be really fast and efficient. There will be some more commands which will be more on the basic side, but I'll start with the most important one so people don't leave early. Yeah. So, okay. This is about rebase. I'll go to the text part later on. I'll go to my shell first. And it is supposed to be an interactive session. If you know something more than what I'm showing right now, it is, so please welcome. You are welcome and come and share it. So now, I always wanted to be a maintainer, but it is really hard. It takes an year of effort to become a maintainer. You have to impress so many people. So I thought this is the opportunity today to be a maintainer. Really. It's so simple. Just take the maintainers file, edit it, remove people, and add yourself. So. You're very smart. You're very smart. I know. But okay, we'll come to it. So that was intentional. Okay. So the idea is I wanted to keep some patches so I can show how I rebase them, right? So this is one of the patches. So I start with the less popular maintainer, I'll say. And I thought, okay, maybe a... Oh. Keep talking. Okay, so, and then hey commands. So I replaced and as well. Sorry, and.
Yeah, I'm still good for adjusting projectors.
Just let's see, maybe he can help you on that, because we want the top of it as well. It's gone. Should I?
Just reduce the size of the tweet.
He can. Let them do it. Good enough now? Okay, so here comes Ant. And I thought maybe I'll go a bit up in the hierarchy. So here is Thomas. I love him. And now that I'm onto it anyway, why leave toggles? Okay, so I'm the maintainer. I'm the god now. So here are a bunch of patches. As he mentioned, I forgot to update the email IDs. That's what happened normally. You send patches to mailing list. There are 10 or 15 of them. You review comments, so you get review comments on them, and then you have to fix all of them. Now, what's the most efficient way? So it's person to person dependent, but I'll tell you how I find it more efficient. How do I do it? The most instinctive way, how anybody who is new to Git, or maybe the oldies also, what they will do is they will go rebase to the base of it and start adding to all the patches one by one. So how do we do it? I may accidentally use many shortcuts or aliases I have, but I'll try not to. But in case you don't follow what's going on, just ask me. So I'm based off 5.3 for simplicity right now. Here are all the patches. What normally people will do, we will mark all of them edit, and then try to fix all of them one by one. So edited this also. Oh.
We trying to help our engineers focusing on what they do in Linaro. So that's what I will do right now.
Thank you. I did something wrong.
Yep, I instead of R.
Where?
That's in the rebase.
Oh,
And now you use. Yeah.
E. I said
E.
E, not I.
Yeah.
Oh, sorry. Yeah, that's like really awesome. Okay, thank you. So what do we do now? So Git is in the middle of rebase. This is the first patch. What we do, we go to maintainers, right? Find Linus, Valley, and okay, we can replace it with Vim with %s and all. So now the problem with this approach, the problem is, I'll take this. So I'll ask for your help later on. So the problem with this approach is that sometimes you have a lot of patches, maybe 50, right? And you have started fixing from the first patch, and by the 12th patch, it is already late afternoon, and you have to go for lunch. By the time you come back, you may have to do something else. So if you have a dirty directory, there are commands to stash your stuff away, but if you are in the middle of rebase, it is really difficult. So you cannot actually leave the rebase at this point of time. Everything will be lost. Or you have to create temporary branches and remember a lot of stuff, right? So this is one of the problems which I see with the normal rebase, that if you have a lot of patches and you are in the middle of rebase, you just cannot leave it, right? So that's the problem here. Now, a solution to it is, don't rebase, be at the top of the branch, and start creating small commits to fix the problems. And then we can squash them later to the original commits, right? So, thank you. No, I'll not speak. No. So I have a couple of branches to just show whatever it was. So
Those were shortcuts.
I know. So it was GLO is git log one line. So okay. So these are the first 4 patches. I don't really like to write a lot. You can see, right? So these are the first initial patches. Now I have 4 more patches which actually fix all of them one by one. So I can show one of them like this one. It's really embarrassing that way. So here I go and fix the email IDs one by one, right? Now, so this is efficient because you are not in the middle of rebase. You can switch branches easily now, right? And you will not forget things. Now, how do I make this process even faster? Okay, and let's try some. So I have created the small patches now. What will I do now? Okay. I'll go here. I have to carefully pick line by line, go this apply here, and write F. F here means fix up. So it will automatically merge with the earlier commit. So I have to do this for all of them one by one. Right? So even this is a process because when there are more patches, like 50 of them, you have to be really careful. I have done it that I have merged wrong fix-ups to the wrong patches, and then it is a mess completely. So now you can actually you can just continue and it will fix them all up, and we will eventually have 4 patches which are all fine. But how do I make it better? So Git has a command which is git rebase -- auto squash. Okay. With that, if the subject of the fix-up patch is defined in a particular way, then it will automatically place them at the right position, so I don't have to jumble through the rebase file.
if you want to back out, you can just delete all the content and it will do nothing.
Yeah, I know. So
Yes,
you
I
can
was
delete-
just.
Yeah, I
Yep.
just my hands are
Just
shaking right
additional
now.
tricks.
Yeah, I know.
Right.
So this is the format of which this is the format which the Git auto squash thing command will pick up. So if this was the main commit, I have to add fix up exclamation mark and space before it. Okay. If I have this magical word before the exact subject of the earlier commit, Git has the power to automatically place the patch at the right place. Okay, so I'll show you. I'll come to that. Yeah, slowly. So I'll show you how it will happen without fix-up first. So if I do this, all the fix-ups are at the bottom, right, and not at the right places. Okay, so with the auto squash thing, Git has placed all the patches at the right place. It had deleted the pick keyword before them and replaced that with fix up. All I have to do now is save and quit, and Git will apply all the patches. Okay, when you have many patches, many small fixes to all of them, it is really, really useful. But we can actually make it a bit more faster. In this version, we had to go and update the commit message by ourselves with the fix up exclamation mark. Even Git has the facility to do that for us. So just some small changes. So suppose we want to add the change to this particular patch. What we can do is right. So if we do this, we have the new patch like this. So nothing at all, right? And now we can do the rebase again with auto squash, and it will place all the things at the right place, and life is good. But we can actually make it even faster. Now, so many times you are really, really confident that there is nothing which can go wrong, okay? And you don't actually want Git to even show the rebase Vim page where you can edit actually. So if I do this now, it will actually open me a page, and I have to save quit it. So, it's like I'm really lazy. I don't want to do it as well. So what I can do is I can play. So with Git, many times so there is a Git editor. What do you call it? It's a environment variable Git editor, which is normally set to Vim, and that's why it opens up it in Vim. We can actually play with it to say we don't want to open this as well. So what I do normally is this. Okay, so I've changed the Git editor to cat, so it doesn't show me what I don't want to see. So it has started applying patches, and after this, there's nothing I have to do. Here are the final 4 patches for me. So this can be really, all these things can be really, really useful when you have 50 and hundreds of patches. So this is not specifically for maintainers, but developers who have a lot of patches to rebase over and over again.
But wouldn't it be the same if you just don't give -e?
Sorry?
Just git rebase auto squash?
The auto squash only works with -i. It doesn't do anything otherwise.
Yep. So I don't think the automatic fix-up thing and all this will happen in that case.
I think it will reject it, but
Yeah.
you can try. Just try it.
I have screwed my thing, but yeah. I'm going there.
Just yeah. That's also a good demo. A lot of people don't know
I
reflog.
had that as part of demo, but later on, not right now. Fix up. 11 is good. Yeah. But this is Linus Valley, not Linus Torvalds. I must have created a temporary branch. Sorry.
That's okay. That was the right one. Take that one, the 11.
one?
Yes.
Okay, yeah. Sorry for the shortcut.
That was
Because
Git
it
reset.
Hard. Very hard. No, so this was the right one. Sorry. Okay, so you were saying without the I we can do it, right?
I said it doesn't work.
Okay. See? It
He
didn't do
said
anything.
with auto squash, but without the I.
That can actually work.
No, that doesn't.
Doesn't?
How many people have tried this before?
No, it doesn't do anything. So, yeah, but for a moment, even I thought that auto squash may actually fix it.
It might it might do that in the future.
Because we are saying auto squash, so it may be the right thing to do it. I don't know. So this Git editor cat thing can be done to so many things. Like if you want to, so if you have a previous patch and so if you have a patch, you made a diff and you want to just amend the changes, we say git commit minus minus amend. So you can add this git editor equal to cat with that, so it doesn't open the subject of it for us to edit the commit log or something, just go on. So we don't have.
-S.
Oh, okay. I just use this everywhere. Okay. Okay. So, okay, and there is git rebase onto as well, which is quite useful. So, I may not show it, but I'll just tell what it is. So, suppose you are rebasing something from a 5.3 branch to a 5.0 branch, okay? In kernel, 5.3 and 5.0. 5.3 has 3 more kernel releases, probably like thousands of more patches over it. If you do a simple rebase, what Git will try to do, it will pick all the patches from 5.0 to 5.3 and try to rebase them as well, which is absolutely not what you want, right? So there is an option Git rebase onto where you can tell the starting and end point of a rebase. So you can say from 5.3 to the next 5 patches, apply them in 5.0. So Git only applies those 5 patches instead of everything it has. So that is, it is rebase. Cherry pick and rebase are different actually. So rebase, you can edit them, you can reorder them. There are so many things you can do with rebase, right?
The result is the same, but the mechanics are slightly different in the details. So the rebase you start on the branch that has the patches. With a cherry pick you start on the branch you want the patches on.
It's just that rebase is more powerful. You can play with the patches, rearrange them during rebase before they get applied or something. No, you cannot reorder patches while doing cherry pick. Yeah.
No, you can give a range.
You can do a range, but
it's harder. You can still
it
do
is
it.
not that powerful. That is it. Yeah. So rebase is much more powerful that way. Okay, one more thing. So there is another thing which I have found to be very useful. It is more hacky than a standard Git command, but okay. So we have these patches right now. So what I will do is I'll merge all of this, okay, the top fixes into a non-commit object. I'll put them into the index or something. Okay. I don't want that. Okay. So what I have now is all the changes of email ID for Arndt, Linus, Torvalds, everybody. They are all together, right? So this is another way of doing a rebase. That is sort of, so many times what you do is, instead of creating patches one by one, because you are maybe not good at managing that way, you write all the changes once, okay, and then you apply them one by one to all the patches, right? You have a big chunk of changes. Now, so I'll show git add -p later on. This is about rebase. So there is another way of picking these changes and applying them to all the patches that we had. Here we have the top commit with all maintainers changes, right, Arndt, Linus, and everything in a single patch. Now, what you can actually do is, you can take this, apply it after every patch, okay? And so what Git will essentially try to do, it will try to apply temp first after the Linus Valet patch. You can keep the part which you want really, and skip everything else. Okay, just let it go. And then Git will again try to apply the same big patch. It will automatically leave the Linus Valet part because it is already applied, and try to apply the rest of it, right? Another thing, so while doing this, many times what happens is that you are rebasing 50 patches, and suddenly you realize that you must have added a patch sometime back. Okay, you just missed applying a patch earlier, or you have done the rebase, you wanted to shuffle the patches, and you forgot to shuffle something, or you wanted to move something later on. So if I do this now, it fails because the name change of Arndt and Linus Torvalds are still not there, right?
I assume you're going to show merge tool later? Are you going to show merge tool later?
No.
Okay. Show it now. Git merge tool. Yeah, get out of there. Revert those changes and get out, and type git merge tool. Yes, you should. No, without the dash. Yes, type vimdiff. Vimdiff. No, one word. That was, sorry. And now search for, go to the bottom window. Yep, go to the bottom window. Control W, done, yep. And now you can see on the left, you see the state of the current tree, and on the right, you can see the state of the patch as it was originally, the patch that you were rebasing. In the middle, you see the state that was the last common ancestor, and in the middle, you can see the merge of the two. So then you can more easily see how you got to the crazy state that you're in and what the merge conflict was that you're trying to fix up.
But I still have to do the same.
It's the same changes that you're applying that you would have done. It's just that when you look at the bottom half of the screen, you get all the information that helps you do the change for the fix-up.
Okay. It's good. So I'll not go and edit everything. I just wanted to show what's going on. Okay. So another thing which you can do with rebase in the middle of rebase is this. So if you go to the .git directory rebase thing, there are a bunch of files there, okay? The first one is git rebase to do, and one is git rebase to do backup. So the to do file is, it shows whatever is left to rebase. So if you're in the middle of rebasing 50 patches and 10 are already done, it will have the rest of the 40 patches. And the backup thing is the original state which is preserved for you, all the 50 patches. What you can do is you can open them and you can actually play with them and do a git rebase continue. At the top is backup file, which has the original state where you were before the rebase, and the bottom one is which is used in the rebase right now. So what you can do now here is go here, delete them, mark something edit. If you forgot to mark edit or squash or something, right? So you can actually go to .git file and play with this file during rebase to make changes which you forgot to do earlier. And this is also quite useful number of times. So that was, I think, more or less about rebase. Anything you want to ask for this? Onto? Okay. So this is my thing. So this is 5.3. I'll try to rebase this patch to 5.2 for faster. And it will still take them some time because there are thousands of patches here. Okay, so
This will fail.
this will kill my VM maybe.
Yeah, this will completely fail.
No. Why should it? It will pick all the patches from 5.2 to 5.3 and
It will serialize them. It will
serialize all the
It will
merges.
try to redo all the merges, which doesn't
It
work.
will serialize it. No, it will actually get all the patches there. I'm quite sure of it. And this is exactly what I want to avoid with ON2.
Okay.
So I'm showing the problem right now and I'll then use ON2. So the problem is it is taking a lot of time because it is trying to find the patches which were there between 5.2 and 5.3 plus the delta I have, which is thousands of patches. Eventually it will open Vim in some time. I don't know. It is Vim on MacBook, on a VM. And there will be thousands of patches there and you can't do anything with that. If you would have used ON2, it would have just taken 4 patches and it would be like a lot faster. I don't think it is going to happen. My VM is dead. No, it is not dead yet. Sorry. I can do that. I just thought maybe like.
So what would happen
really
then is you get all the thousands of commits, but not the merges. The merges you also get if you use -p in addition to -i.
Right.
Then you can rebase through the merges and leave out merges without getting all the individual commits that come from the merges. That is fairly useful when you're a maintainer who's pulling in branches from other people, and then you want to take out one of the pull requests. That's where you use rebase -i-p. The way you do it here, you get the thousands, like 10,000 patches.
Right.
And if you try to actually run the rebase, then it fails as soon as you get to the first merge that failed, that Torvalds resolved, or somebody else, and then you have to do the same resolution, which is basically impossible.
Okay. So I didn't complete the whole rebase. I did a Control-C and I opened the Git rebase files just to see if they have a state update, right? So this is the file, and we have already 14,000 something patches from 5.2 to 5.3. And the last 5 are ours, and everything else is from 5.2 to 5.3. See? It's 14,000 lines.
But now you can remove everything as other than the last 5 lines.
Yeah, but we didn't want it this, right?
No, but that would be now that you're there, you could just remove everything
Right.
up to
So
from the
if
start.
you really want to do the rebase, you can remove those and you can just keep the 5 patches. But I want to show ON2 now.
Yep.
So with ON2, there are 3 things you need to provide. The branch you want to rebase, the starting point of the rebase, and where you want to rebase. Okay. So the first thing is where you want to rebase, 5.2, if I remember correctly. Okay. So, and then maybe these are 5 patches ahead.
Yeah, you don't need to pass another argument. Two arguments are fine. That's enough.
Okay, so 2 arguments fine if you are on the current branch, but if you want to rebase another branch which you have not checked out yet, you need the third one as well.
Yep.
So
And you don't need -i here.
yeah, the SHA, the commit, the branch name.
You don't need -i. You don't have to
Yeah,
do it
so
interactively.
it was there from my previous time. So, but will it still be interactive without I?
No, it won't, but that's fine.
Yeah, but I want interactive.
Okay. Well,
Normally
then
I want interactive.
If you want it, then you have to. It's actually when you're doing a long rebase, like if you have 300 patches on a tree and you just want to rebase it to a different head, then doing -i makes it much slower. It takes like half a second for each commit, whereas without the I, it takes like a fifth of the second.
Okay. Okay. So see how fast this happened now, because it just had to pick 5 patches, like cherry picking 5 patches and applying them there. This will take some time now because it has to check out the complete directory. And it's going to reply as well because there are changes. But if you see, we are on 5.2 now.
Just skip that one. Okay.
So that was rebase. Now there will be some more commands which I will show, which will be much quicker than rebase. So, okay, I'll start with work tree. So one of the particular use case I was looking to solve a long time back when I found this work tree command is, I normally have to work on Android and non-Android, Ubuntu or plain kernel version, right? If I check out my normal mainline kernel somewhere in a repository, I cannot work on Android unless I switch the branch. But many times I don't really want to switch a branch because it takes time. Then the build takes time because we have a new source, the files have changed and everything. So how can I have two different checkouts of a repository? Right? One way out is you clone another repository, but it will have all the Git objects separately stored. You can be smart to share the existing ones, right, with clone with reference thing. But still, whatever new you create, it will be part of different repository, and you have to add a remote repository to the other one, fetch things to get the changes, right? Git provides a way, which was added maybe a few years back, where you can actually share the .git directory between multiple checkouts. Okay, so what the command is like this. So this is the Linux directory. If you see back, there is nothing. What this will do is it will go to the back directory, create Android, check out a branch named Android by default. You can give the branch name as well. And this is it. So we will have 2 folders now. Both of them are sharing the same .git folder, which means they are sharing all the objects which were there. So you create a commit in the Android directory, and the same objects will be available in the Linux directory, which is really, really useful many times. So you can actually check out multiple branches out of the same repository. So the new one doesn't have a .git repository at all. It has a link to it. It only has a .git something something file, but everything happens in the main Git directory. Show which are the directories you have created out of it and all. And you can delete that, prune it here, and they will be gone. So I normally keep 2 Android and Linux, which are.
It's a file, right? Can you show it? Just cat. Or just cat.git.
Oh,
it's a file.
I was showing all the files. Sorry? So you cannot check out the same branch at both the places. Okay? You cannot check out the same branch at both the places. And a branch cannot be deleted if it is checked out in any of them.
So, for example, if you're It will have the same .git object database, but then your directories are different, and you can compile them differently, and you can work on different independent branches at the same time with the same Git objects. And then if you commit something on, let's say, upstream, and you want to cherry pick that on your next, you can just say cherry pick because the same Git database.
So if we check out a different head on one of the projects, the other project remains unaffected.
Yeah,
Still
completely.
continue to see. I see.
Completely.
Okay.
It's like two different clones. It's like two different clones, just that the objects are shared.
But the one branch only corresponds to one work tree. You cannot have the same branch checked out.
At the same time.
Yeah.
Yeah.
Okay.
You can check out them later on, like you can switch the branch here and then check out that there, but not at the same time.
Oh yeah. Very helpful. Thank you.
Yeah.
Yeah.
So there are other commands for which I may not show a practical thing here, but I'll just talk about them. So there is git stash. So many times you have work tree which is dirty, you have changes, and suddenly you realize that you need to change the directory, the branch, right? So one way out is you create a temporary commit and you move on, right? Other way is you use the git stash command. So it will actually create a temporary commit for you. If you see the list of stashed objects, you will find them there. You can check out them later on, reset to them, and you can find your dirty stuff later on. Okay, all the dirty changes. Yeah.
The Git work tree, how is that different, or how does it compare against Git new work directory?
So don't use new work directory anymore because that was a bunch of shell scripts around this thing. Git work tree is like the official way to do the same thing now in Git.
Maybe the same patches got merged finally.
No, I think
I'm
that
not
was
sure.
just a bunch of shell scripts around that. I think this is.
Okay. Yeah, this got merged.
Yeah, that's true too. Yeah, this is the new way of doing that, but it'll achieve the same thing.
So, so git stash is done. Now git reflog is also quite useful. Like just some time back, I made changes to to my branch, and I wanted to see an earlier state of the branch or where the head was at earlier point of time. So. So this shows the location of the head, all the previous locations of the head, right? Head is the currently checked out commit. So this has list of everything I have been doing since ever. So you can actually pick any of, so these are the SHA IDs. You can use this or you can use this to check out a branch, look at it, log and everything. So this is kind of history of where you have been. So you can go back and use it later on. No, so this is your directory. Yeah, it doesn't have anything to do with the remote stuff. Then git clone, everybody uses git clone. Sorry. Everybody uses git clone, but with reference you can actually share the objects. So if if I have a Linux repository already on my system, and I need to clone again the Linux master. If I clone it, it will actually pick all the packages one by one from over the net, and it will be very slow. With reference, it will actually pick all the packages from my local directory, and we can actually share them as well. With without disassociate, we will probably share them. With disassociate, we will make a copy of them, but it will be much faster. But any new commits will not be shared, right? And that is where Git work tree is useful.
Or you actually never do a clone. So what I just use git remote add plus git work tree. So I have one copy of the kernel in Git, and I have all kinds of remotes, and I have all kinds of work trees. But I never need to clone. I just always add a remote, fetch that, and then check out a work tree.
No. So it is not for that purpose. So many times people for testing, for example, the Lava guys and all. So the Lava guys, they actually have to clone every time a new work tree for testing our branches or something.
They shouldn't have to. So even what I do exactly same. So I have a
not
Git.
for us, but I have seen their scripts, and what they do is with minus reference 1, so they don't clone the entire history, but just the top commit to test it out.
No. So if you have a local setup, I also have like a Git cache folder Where
I
I have
understand, but
added
they are
Git
doing
remote.
50 tests in parallel.
Yes.
So they need 50
No,
repositories in
they
parallel.
don't need it. You can do it either way. The result is almost the same. You can do it either by using clone dash reference, or you can do it by git remote add plus a work tree.
Okay,
You get
I see.
the mechanics
It will
are slightly
actually add a
different, but
different
the result
directory.
is the same. You only have one copy of the objects, and you have one copy of the tree
Okay.
that you want.
I see.
So I actually had a question. When I do a work tree, I actually looked at the size of all my trees the other day, and everything was like about a gigabyte. Is that because it's a hard link into the objects directory?
So I think the checked out tree is about a gigabyte, isn't it?
Yeah, it will be a gigabyte anyway because
The files.
Every work tree is a gigabyte.
Yes, every time you check out all the source files, that's about a gigabyte. Yes. So if the .git directory becomes too big, you need to git GC to garbage collect it. But they usually, if you do that often enough, then the files are actually much, much bigger.
So see, Android, which is hard-linked tree, is 987 MBs, while the real Linux is 5.5 GBs with the Git directory. So Git reset, it is quite useful and it is quite dangerous to use. There are multiple versions. So Git reset hard will. So Git reset minus hard, it will set the head to the particular SHA key. It will clear the index. It will clear the uncommitted area, and everything will be lost. So you have to go to reflog and see things again. Whereas Git reset minus soft. So if you do a Git reset minus soft head tilde, it will keep all the changes which were there in the commit in the index, but not in the uncommitted section. So they will be in the index, but the commit will be gone. If you do a minus mixed, they will not be part of the index, but they will be in the uncommitted section. You understand, everybody understand, right? The uncommitted section, index, and the commit, right? Sorry? Keep. I completely forgot about it. So I made this presentation years back, and I did it for PMWG at that time. But so I tried to revise everything, but I actually forgot keep. I forgot to revise keep today. Maybe we can check. Also, if you have, so when you are doing git reset minus, when you are doing the git reset, if you actually had more uncommitted changes, it will actually keep the latest, your uncommitted changes and not touch them. So it will keep them. Checkout, we all do checkout, so we can, if there is already a branch, we can do checkout branch. If we want to create it while doing a checkout, we can use -b. If we want, so if we are on branch, if we have branch A and B, we are currently checked out branch B, and we want to have a particular file, the content same as that from branch A, we can use git checkout, the SHA key or the branch name, and then minus the file name. So the file, the uncommitted file will be same as what was the version in the SHA key or the branch name.
So that only updates that file?
Yeah, only update that file. That was the idea.
So you're sitting in branch A, you do that, and you're pointing at branch B, then it only takes branch B's version of that one file.
We can do it now.
Something about that has changed in the latest Git release. There was some announcement, I forgot what it was, but it might not work anymore. Or maybe they made it easier.
So I have checked out from 5.0 now, so you see all the differences. And only this is git status, so only one file is changed. So this is to check out just a particular file or something. So we can play with git add a bit. Okay. So this is all the fix-ups we had, a commit of that, where we were fixing the email IDs. So this is git diff ---- cached. We need git diff actually. Okay, so we have all the changes here. Now what we wanted earlier was to pick Linux Valley changes to the Linux Valley commit, in that way. So many times we are at the bottom of all the 50 patches. There is no rebase going on. We made changes, so many of them, and now we want to separate them out. Okay, so I have seen people doing it the stupid way, keeping copies of the file manually separately out of Git and doing things. So there is something called git add -p, where Git will come and ask you if you want to put this diff into the index or not.
That makes no sense on a new file.
Sense, yeah.
You cannot partially apply some of the changes to the new file. And then you can use git commit-p and use edit to edit it while you're committing. That would work. So commit-p is a shortcut for add-p and commit.
So if you try to do -p to a new file, this will happen. No changes, because there is no history of it. I just made a new file XYZ and try to do it. Okay. So actually I did the wrong thing. Wait. What's that? Let's try now. Says the same thing. Okay. So this is what we had. So we are going to try the add -p thing now.
No. It's better.
It's far better. So this is more powerful, I'll say. So it is asking me if I want to add this particular diff into the index or not. I can say yes, no. If you can actually edit it, and you can edit it a lot as well, unless you make it controversial, like Git cannot apply it.
And
Sorry?
hunk by hunk, yes.
Yeah,
And you can
hunk
split
by
up the
hunk.
hunk.
And if there's a big hunk, actually, there's a split thing also, so it will actually try to split it as much as possible. And you can actually edit it later on, so at that time itself. So I'm saying no to this, Linux Valley, yes. Sorry? Okay, so I want to say, okay, I'll change my email ID here. So if I say E, it will open Vim.
And then you have to be able to edit diff files, which not everybody is used to.
Especially when you have to undo or delete thing. It is really
But this is very forgiving. If you don't have to edit all the plus minus lines.
You can edit. So I can edit that.
Yeah, add him.
I can edit here. But I have to add plus as well, I think. So that's it.
No, you don't have to change the line count. It will ignore that.
So it's done. So you can see it now. So if I quit it in the middle of it, it will not apply the rest of the hunks. I can do, so this is, okay. I'll just type it down. Cache is used to see what is in the index instead of uncommitted section. So here you go, right? Now with -p, you have added only a selective part of the whole uncommitted message to the index. You can commit it, and then you can again do a git add -p to selectively add things and make a new commit.
And it only changes stuff that's in the index. It doesn't change the content of the file itself.
I found it convenient when working on with git add -p. Sometimes you have a chunk and you have two changes in it, right? And -p will only allow you to commit that chunk in one change, but not two, right? So what I do is I open the file in a separate editor in another window, and I remove one of the two changes, save, run git add -p, take that change.
I'm not sure I followed you.
Yeah.
Sorry.
So say you have one chunk, but into that chunk there are two things that you changed, and they belong to two. Say you want to fix up two different changes with those, two things that you did, right? So they are completely, they belong to different changes. So if you
that's what you just showed.
That's
what it does.
Okay.
This is easier.
So what you're saying is that even with split, you cannot actually split the hunk anymore, right? And you want only a part of the smallest possible hunk to be applied. So what you can do is edit it there. Don't add the So okay, I'll show you.
Show him how to remove the minus line or the plus line.
Maybe okay. So suppose this is the hunk, right? So what we have here is okay. So this happened. You know why this happened? Because so we just added this line, right, which is shown in red here, and it is showing a different story altogether now. Because we never updated the file, right? The end file which is there in my repository, it is the same. We are only playing with Git and its index, right? So initially, there was no this line here at all. Even if we actually added it to the index and to the previous commit, it does not matter because the end file still doesn't have it. And that's why it is removed here. You got it? No? No, it is not. It is not. It is not.
No.
It is not.
No, it's in the commit. When you
It
commit,
went to a
that
commit.
line will be there, and then the index still has.
I can remove it in the next commit and add it in the previous commit. So it is useful many times actually. So okay, let's play with what you were saying, right? So what we want is, so if I do split here, it will not split because this is the smallest hunk possible, which it can play with. But what I wanted is, I don't want this to go with it, for example, okay? And I want a modification to this as well. So what I can do is, I can go do edit. If you read this part of it, it tells us how to actually edit it. Okay. In the beginning, it took me a few days to figure out how minus has to work, but it really works. So what you have to do is, in the plus line, you can go and do anything. Okay. So Viresh K1 I can do, and it will just work. In the minus line, what you have to do is remove the minus sign and add a space there. That is it. If you do it, so that line will not get subtracted from it now. And I can do quit now, and this is it. It will be there. So because I didn't clear the index from earlier, it will still be there. But
so you're editing the diff, or you're editing the file? Editing the diff. Okay.
And
that's what will be used by
the index
GitHub.
and not with the file. The file is untouched. Actually, the end file is still the same.
The diff is only added in the index.
Okay.
Yeah.
Okay.
I'm only playing with the index and the uncommitted part. Nothing else. Cool. So edit is quite useful in this case. P minus P.
Oh, sorry. How is git commit minus P different from this?
So git commit minus P is git add minus P plus git commit with nothing else. So you can do git commit dash fix up dash P file, and then combine all the things we learned here.
Yeah. So whatever you have added, it may just commit in the end.
Yes. So you just commit one of the lines with a fix up line with the subject, and then you can commit the next line.
So unless you guys want to mix the next session, we are over time now, so I'll just continue slowly, if it is fine. Right? There is nothing interesting anymore. So
One doubt. What's the difference between git diff cached and git diff staged?
Stage is for what?
Never used that.
So cached shows index. I don't know what stage shows. Or is there a stage? We can see. There is no stage. No. I'm sorry. There's only cache.
Staged is a synonym of cached.
So we call things as stage when they are in the index. Okay? And there is no minus stage here.
It says stage is a synonym of cached.
Okay. So it is not in the latest Git. So I normally compile the latest one, and it is not there anymore. So it's gone.
Old version of Git, I guess.
Yeah, all good. So maybe they had both of them for some time. Yeah. Okay, so that was Git add. Now the story of double diff and triple diff. I get confused sometimes. If I'm wrong, I'm sorry. So
Git
there is-
log uses the opposite meaning of git diff.
yes. And even it is more confusing, I'll say, because I had a discussion with the Git guy some days back, and what they said was like completely over my head. I couldn't follow anything at all. So double dot and triple dot. So if you are doing a git diff, when I do a branch A, double dot branch B, it says that what is there in branch B, but what is not there in branch A. So suppose there are 2 commits in branch A, 3 in branch B. It will show all the 3 in branch B as plus, and all the ones from branch A in minus, right? Right. So you will see the changes from both the branches, 1 in plus, 1 in minus. If you do a triple dot, it will find the first common commit between them. So if this was the B, it will go here, and it will show the difference between branch B and this common part. So we will not have the stuff from A in negative anymore. That is triple dot. Again? Somebody wants, okay. So these are the 2 branches, right? Branch A and branch B. If we do a triple dot, we will only see this in plus. Only this in plus. This will not be shown. With triple dot, we just find an intersection of these 2. With double dot, we will see this in plus, this in minus. Good now? Okay. Intersection means the common base of them. Like 5.3 is a common base for 2 branches. Yeah, common ancestor. So while at it, I can do git log as well, double dot, triple dot. So log works a bit differently with double dot, triple dot. So with log, when I do git log A dot B, this is B, this is A, it will show me the commits which are reachable from B but not from A. That will mostly be just B. Sorry? You are on the phone? Really? Okay. So, so when you do A dot B in git log, okay, it will show me the commits which are reachable from B but not from A, which means the commit only which are in B. Okay, this is it. This to the common merge point. So the common ancestor onwards. Opposite to what? So what was there in triple dot? It is here in double dot. Don't ask me why. Okay. And then there is triple dot. In triple dot, we see what is reachable either from A to the common ancestor or from B, but not both. So that makes it common ancestor. So it will show A plus B in that case with triple dot for log. Because people have to see the commits in different ways. So yes, it is use case specific, and you may want to
ways to run git log, and they're all useful for somebody.
No, so I don't know what it will do for A dot B in cherry pick. It will be really screwed. So it should be a single branch for cherry picked A dot B.
I don't think cherry pick takes the 3 dots. It
3
will
dots,
take
no.
whatever. When you use the 2 dots, it should take the same as git log with the 2 dots.
No, but I don't know what Git will do if we have 2 branches A and B, and A dot B if you do with cherry pick. It will be. It is
I
nonsense.
think it will use the same set of revisions as log shows.
Maybe, okay, maybe, yeah. So maybe it will just pick A and nothing else.
Yep.
Then maybe there is a triple as well, so it will pick both. Yes. We never know. Git is smart. We are not. Yeah. So that was Git. Okay, we had actually log. So that was double dot and triple dot. We have a reverse version as well. So when we do git log, it shows from top to the bottom. We can actually reverse it, which is very useful sometimes. There is a -p option, -p. So with git log, simple git log, it will only show the commit and the sign-offs and all. With -p, you can actually see the commit as well. Okay, the whole commit during the log. So, okay, I'll show maybe. So if I do a git log like this, it shows up to 5 to 3. I can say so from 5 dot.
Yeah, that says reverse. You can't see it on the screen again. It's not visible on the screen.
Oh. Okay. So
Too many. No, 3 dashes. Yeah.
oh, sorry. If I do this, it is showing it to be in the reverse order. If I add -p as well, it shows the commit changes as well which is quite useful many times, depending on what you want to do. So that was git log, git show. Okay, I'll skip a bit of them.
Ancestry path is very useful for git log when you want to see what got merged, but not, like what merges were there, but not all the contents that were merged, just the merge commits. Like if you're looking at Linux Next, git log -- ancestry path will show you all the branches that got merged into it. But it will not show all the commits that are there, because those are usually not interesting.
And there is another one which is useful is git log -- follow. So what happens many times is a branch gets renamed, right? So you had a cpfrag.c file, it is changed to cpfrag1.c. If you do cpfrag1.c, it will only show you changes up to the time it was first renamed. With -- follow, it will follow all the changes up to the first time it was there, right? So that is also quite useful many times. Git, so we have grep and we have git grep as well, just like Git. So it is much more efficient to, so you can check out branch A and you can grep in branch B at that time without checking it out, right? So that is quite useful. Git bisect is, maybe most of the people know it already. It is, so if some patch has broken the build or testing for you and you don't want to test all the patches one by one, there's git bisect, which will do it in a binary search way. It will take first and last patch, test the middle patch, test the middle patch, and you can do it much faster, the whole testing thing. Yeah. Merge commits?
That's fine. That's no
Yeah,
problem.
Git will find by itself, it will do. Yeah. So, okay, because somebody asked me about this push thing. So, normally you can just push a branch, right, with git push. Sometimes what you want is you want to replicate your repository as it is somewhere else. So what I do for many of my repositories, like scripts and even Linux, I have a cron job which pushes them every day at 1 in the afternoon to a backup server at Linaro somewhere. Okay, so there is git push -- mirror, which will duplicate your all the branches you have to some other repository. It is very good for backup and that kind of stuff if you want. That's it. Thank you. Any more questions before clapping? Okay, we are already over time. Thank you.